All right, hello everyone. Welcome to first real lecture. I'm going to be going over the overview of geospatial technology. This is chapter 1 in the textbook. So, what is geospatial technology? Describes a number of different high-tech systems and tools that acquire, analyze, manage, store, or visualize various types of location-based data. Some geospatial technologies, they're encompassed in several different fields and techniques. Of these are geographic information systems, or GIS, remote sensing, global positioning systems. I'll go over each of these throughout this lecture and give some examples. So geospatial technology uses, the federal and state governments use it, forestry uses it, law enforcement uses it, public health uses it, biology, environmental studies, even going as far as like video games can use it now. I'll give some examples of that a little later, but pretty much just about every industry uses it. It's super, super cool how often we see it here in society. So, what is geospatial data? It's location-based data, and it's what's at the heart of geospatial technology. Basically, when you want to know the where for something, that's the geospatial concepts. That's what geospatial data is the where. Think about Apple's Find My network. When you lose your iPad or your AirPods, or that super annoying notifications of, hey, you left something behind, or hey, something is following you. That is a great example of geospatial data. Is that location of checking to see not only where you are, but where that additional device is in relation to where you are, to let you know whether something is being left behind or something's following you, or whatever. It's not just limited to point locations. Think about like the length and dimensions of a hiking trail. So if a hiking trail is 2 meters wide, but then it narrows down to a meter wide, a mile, that's all geospatial data. Even like buildings and the outlines of buildings. So what the actual like square footage of a building is. Each of those points in the square footage is geospatial data. So like same thing with borders, like state borders, country borders, just to figure out where a boundary line ends and begins. And then satellite imagery as well is also a form of geospatial data. We're constantly looking at satellite imagery like on Google Maps and stuff like that. So definitely makes sense. And then there's also non-spatial data that can be used in conjunction with spatial data. So what is geolocation? Basically, it's determining where something is in the real world. So using, again, go back to the Find My example from the last slide. When you go to look up where one of your devices is, like an air tag for your backpack or keys or wallet, or even you're trying to look up, where your mom or your dad is in relationship to you. That's all, geolocation. Same thing with like Strava as the other example on this slide. Basically, it's mapping out like a running route or a hiking route or a biking route. That's all geolocation. That's essentially a group of geolocation points in order to figure out the actual route that you ran, biked, hiked, whatever. So ubiquitous mapping, it's this is a quote. So it's the use of creation of maps by users anywhere at any time. And then GIS is a way of speaking the language of geography, and it's geography in action. Those are both quotes from Jack Dangerman, the founder of Esri, from an article back in 2004, I believe. Both of these are, great descriptions of GIS and ubiquitous mapping. For example, when you use an in-vehicle navigation system to navigate through unfamiliar territory, or use an online tool to examine housing values for your neighborhood, you're using basic geographic concepts of space and place through technology. Geospatial technology gives us the tools to apply location-based principles to real-world situations more easily. For example, how is the new freeway bypass going to affect the local community in regards to traffic flow, new commercial development? So like if a mall's being put in, or individual properties, or what are the potential impacts of the site chosen for a new casino development in relation to land use, economic and social effects, and the draw of gamers from far outside the local area. So throughout the textbook, you'll be working with geospatial technology concepts and application, using geospatial data, measuring spatial characteristics, and examining spatial relations. So where can you find geospatial information in the real world? A couple different examples here. First of all, we have Yelp. Help you figure out where you want to eat, shows you some good options that are relatively close to you. Second option is I have a somewhat generic looking weather app here. Basically, it's pulling in your geolocation in order to then essentially query a database for the weather in that area, in order to tell you, what's the weather like, or what's the temperature outside, what's the weather like today, is there rain in the forecast, so on and so forth. And then as a last example, I have Zillow. So basically showing you a bunch of different points in terms of houses that are for sale in the Rochester area, and what they cost. So all really good examples of geospatial information in the real world. So then, what is Geospatial Information Systems, or GIS? So combines layers of information, basically data, to have a better understanding of the location, and then GIS slices the world into layers, as it shows in the example image on the right. So basically, to just kind of explain the image, we have the real world down here. This is what all of us are living on, and then we have the land usage, so how the land is actually being used. Some of it could be farmland, some of it's residential, some of it's big city. We have the elevation, and then we have elevation being the terrain and how the landscape actually looks, and then we have the parcels and the streets. So basically making up how you can travel and transport goods and stuff on the actual surface. And then last but not least, we have the customers, so people who are actually using the goods and services in the real world. So on to virtual globes. So a couple different examples. We have Google Earth here, and then we also have ArcGIS Earth. So virtual globe is, basically what the title is. It's a virtual globe. And they're a program that provides an interactive three-dimensional representation of Earth. They bring together several different aspects of geospatial technology into one easy-to-use program. You can use satellite imagery and aerial photography of the entire globe, and zoom in from essentially Earth's orbit or Earth's atmosphere down to a single city address, and navigate through 3D cities or landscapes. You can measure global distances and examine multiple layers of spatial data together, all with an intuitive interface. So Google Earth is probably a little more well known than ArcGIS Earth. We're going to use it in the first real homework assignment that I will explain at the end of this lecture. Oops. Spatial analysis and geoprocessing. Spatial analysis is the examination, the characteristics or features of spatial data, or how features spatially relate to one another. Basically, how many objects of a particular type are within certain distance of a particular location. How do we choose the most suitable locations based on a set of criteria? So what makes this particular area good for farming versus what makes this particular location well suited to, house a Starbucks, basically. It's basically going through and analyzing different, attributes and, even going as far down as, what does the actual terrain look like? What elevation are we at? Can crops grow here? Obviously, it's a little different now, and farming isn't necessarily the best example. That's what spatial analysis and geoprocessing are. So this is a very early example. This is Dr. John Snow's work during an 1854 cholera epidemic in Soho, central London. It's a relatively poor, overcrowded square mile of narrow streets and alleyways, and his analysis was able to identify the infected water from one pump as a source of the outbreak. At some point, Snow mapped the location of the cholera deaths in relation to the water pumps. That's what this image is. And this type of spatial analysis relating to location of cholera deaths to the positions of water pump was innovative for the mid-19th century, but it is very, very common today. We use GIS and these types of spatial analysis problems. This specific, a specific type of this problem can be addressed somewhat easily. This is another example, a little bit more of a modern example of John Snow's maps and what he actually was able to identify. Okay, so GNS versus GPS. So GPS, I think hopefully most everyone knows what GPS is. It's a global positioning system. It's what we all use on a pretty regular basis, or if not a daily basis, for like routing, trying to figure out where we want to go. We're in an unfamiliar area. We're going to use GPS in our phones to figure out where we need to go. And then GNSS is the Global Navigation Satellite System. So GNSS is used in collaboration with GPS systems to provide precise location positioning anywhere on Earth. They work together. Main difference between them is GNS is compatible, has compatible equipment and can use navigational satellites from other networks beyond the GPS system. And more satellites means increased receiver accuracy and reliability. All GNS receivers are compatible with GPS, but GPS receivers are not necessarily compatible with GNSS. So cool little compare and contrast. Here's an example of GPS. So obviously I mentioned GPS in our smartphones for, we're not sure where the closest gym is or something like that. So we're going to use GPS to figure out the where we're going in terms of the gym. And then, Garmin's a good example for especially like a hiker. These are small little GPS units that connect to a satellite in order to map where we're going on a hiking route. It's used in a lot of devices, and we use it on a regular basis, such as smartphones and computers. You can also think about when you, go on a website. I can't think of a good website, but you go on a website, something you're trying to buy something, and they, maybe they have local stores near you. and you want to do like a store pickup, like a grocery store or something. So it'll ask you, it'll give a pop up that whatever web browser you're using will ask to use your location. That's an example of GPS in action along with these two. So these are imagery from satellites and sensors. So synthetic aperture radar, or SAR, it's unarguably the most important tool of remote sensing, and it has widely been used for Earth's remote sensing for over 3 decades. It's an imaging radar mounted on a moving platform, and unlike traditional optical satellites, SAR-equipped satellites operate in a different manner and are superior to traditional satellites. So these are some pretty cool images from those satellites. So web mapping, I apologize for the really low quality picture. This is a picture from ArcGIS Online, and then there's, of course, also Leaflet, Google Maps, and a couple other different examples. But these are basically applications or websites that you can go and view maps online. ArcGIS Online we'll get to a little later in the semester, but basically ArcGIS Online allows you to actually go and import layers and data and tables into your map and then visualize it as well. So there's a bunch of different layer types that you can bring in and view. It's pretty cool. So we'll touch on ArcGIS Online a little bit later in the semester. Oops. So creating maps with code. So here we have a picture of, I think this is actually a picture of Leaflet on the left. OpenStreetMap's Leaflet. So you can go through and create code. This is also a picture of the ArcGIS JavaScript API. As of recording this, as of like last March, actually, the JavaScript API has been retired. So it's no longer you can still use it, it's just no longer receiving updates. And then there's actually additionally a ArcGIS Python API or SDK that you can use to create maps as well. All of this stuff is super cool. This is a lot closer to what I do, which I'll actually talk about exactly what I do on the next slide, 2 slides. So maps and apps, these are software development kits that allow you to create applications specifically for maps. These are all provided by Esri. However, I'm almost certain that there's other companies out there that make similar products. So starting on the right over here, this is the Swift SDK. And then moving over one, this is the Kotlin SDK for Android, so iOS, Android, and then last but not least over here we have Flutter, which allows you to develop for both. Geospatial technology in games. So we have I have 2 examples here. Pokemon Go, which I think is pretty well known. It took the world by storm in 2016. Had everyone running around all over the place chasing Pokemon. Essentially using your real world location in order to track where you are and show you different Pokemon based on where you are. I do remember there was a thing that if you were closer by water, you were a lot more likely to find water type Pokemon, which was pretty cool. And then this is a much more recent Geo game, but The Witcher Monster Slayer. It came out in 2021. I'm not super familiar with it, but it is a game that uses geolocation. So if any of you have played it, definitely let me know. I'd love to hear what it's about. Maybe post something in the Discord and like the off-topic channel. That'd be pretty cool. All right, using the real world data in games. So this is exactly what I work on. These are the ArcGIS Maps SDKs for Unity and Unreal. So Unity's up here in the top, Unreal is down here in the bottom. Basically, it's somewhat simple. It just allows users to bring map data into the game engines for visualization purposes. So both of these pictures are the same, just in different engines. So I'll talk about Unreal over here. Basically, you have a base map, which is what this water is, and then the ground layers as well. Then you have an image layer over here, and we'll get into layer types a little bit later. We're just going over some of the basics right now. But this is an image layer that you lay on top of your base map. It's usually used for like a specific kind of data set. So, for instance, an image layer could be different colors for, the average miles people have walked on a block, for instance, in a specific city. So super specific example, but yeah. And then we also have 3D buildings. This is a 3D buildings, a 3D object scene layer of San Francisco. So this is a picture of San Francisco Bay running in the ArcGIS Maps SDK for both Unity and Unreal. So on to OpenStreetMaps. So OpenStreetMaps is a map of the world, and it's created by people just like you and me, and it's completely free to use under an open license. So we will be using OpenStreetMaps in this first assignment. So it's pretty easy. Hopefully it's easy to understand, easy to use. I just went and quickly pulled up Esri's Redlands campus. So yeah. All right, on to OpenStreetMaps versus Google Maps. These are two free to use online mapping tools. So they both act very similarly. Google has a few more features than OpenStreetMaps, I believe. Obviously, Google has their own Google Maps app on your phone that does navigation. Not too sure about OpenStreetMaps. I can definitely find out and get back to everyone. I'll post something in the Discord this week after I dig into it a little bit more. So yeah, they're both easy to use, and we will be using both of them throughout this week. And then last but not least, the social implications of geospatial technology. So I'm going to go ahead and read this prompt out. This is going to be a homework question, so you'll have access to it on the homework assignment. So think about this scenario. If you own a property like a house or a business, and then that information is part of a public record with the county assessor's office, and it's likely available online. Someone can type your address into an online GIS and get a map showing how to travel to your property. In addition, the dimensions, boundaries, and high-resolution image of your property can be obtained easily. It is possible that the other information can be acquired, such as close-up photo of your house taken from the street and accessed directly from a website. All of this is free, publicly available information that can be obtained with just a few clicks of a mouse. Anonymity about where you live or work is becoming a thing of the past. What does the widespread availability and access to this type of spatial information mean with regard to privacy? If anyone with an internet connection can obtain a detailed image of the house you live in, has your personal privacy been invaded? So like I said, that's going to be one of the homework questions that you guys will have to answer. So that is the end of the slides. Obviously, if anyone has questions, definitely come talk to me and let me know. So real quick, before I end things off, I'm just going to go over the homework assignments. So we have assignment 0. This is basically just get your computer set up with ArcGIS Online and downloading ArcGIS Pro. I added everyone to RIT's ArcGIS portal. So if you haven't done so already, check your email. You're going to need to create an account. And then from there, you're just going to go through these steps in Activity 2 in order to download ArcGIS Pro, create your account, and get it all set up. As for assignment number 1, this is more like assignment 0, part 2. This is just a quick 10-point assignment. Basically, just introduce yourself to the class. Send a brief message in the Discord server, in the introductions channel, just introducing yourself. Explain, what you like to do in your free time, why you chose to take this course. Let us know your name. And if you have any preferred names, preferred pronouns, all that kind of stuff. And then please also change your nickname in the server to your preferred name as well. And then I will go ahead and just show everyone what exactly it is I would like to see for this first assignment. So let's see. I'll just use this message from Allison, who joined the server earlier. You're basically just going to go click on more on the message and then click copy message link. And then all you have to do is paste that link into the submission box on my courses. Should be pretty simple. If anyone has issues with it, definitely just let me know. I'll be keeping an eye on the Discord server this week. Oh, also, while I'm here, make sure when you join the server, you navigate over to announcements. Just read through all these two messages basically, and then go ahead and react with this globe. And it should give you the role to access the course. So you'll have this IGME 382 role in order to access this IGME 382 course channels. So yeah, hopefully that's somewhat explanatory. But again, if anyone has issues with it, definitely don't hesitate to reach out. Okay, on to the real assignment. So this is going to be your first real assignment. It's going to be due on January 24th. So like I said in the first lecture, you should have about 12 days to do it, I think, if I did that math correctly. Basically, you're just going to answer the following questions. Questions 1 through 8 will be worth 5 points, and question 9 will be worth 10 points. So just answer the questions. Most of them are short answer responses. Number 9 is hopefully it should be a little bit longer of a response. You guys don't need to write like a 5-page paragraph MLA formatted paper or anything. Just like a full paragraph or so should be good. And then questions 4 and 5 are going to be screenshots. Oops. How did I do that? Questions 4 and 5 are going to be screenshots. And then number 7 is going to be a link to a Google Earth. So yeah, and then for your Google Earth, just make sure you either add me as someone who can view it, or change the permissions to anyone with the link. And then just go ahead and do this in like a Google Doc or a Word doc or something. Just something that's easy to upload. It is a upload submission on my courses, so go ahead and upload it there. And yeah, that should be just about it. Most of these questions I went over in the PowerPoint. For at least the ones that are like short answer responses. Obviously, examples of geospatial data, GPS, and applications that use geolocation, you're going to have to look around for those. And then 4 and 5, you'll have to do a little, be interactive with it. But I explained GPS and GNS, so hopefully you guys can find that answer. And then you'll need to give an example of a GeoGame, and then obviously number 9 is that last slide I talked about. So yeah, hopefully that should cover about everything. If anyone has any questions or concerns, go ahead and send them in the Discord server. I'm happy to answer them for you guys. But that should wrap it up for week number 1. Next week we'll have 2 real lectures, so be on the lookout for those. Feel free to reach out to me if you guys need anything. Of course, if you need like office hours or anything, just send me a Discord DM or an email or something like that, and I'll get back to you guys as quickly as possible. So with that said, have a good first week, everyone, and I will see you in the next one. Thanks.